golden brown, texture like sun, lays me down. With my mind she runs throughout the night.
Okay, number 3 asks us to find an angle theta in between 0 and 360 degrees, or 0 and 2 pi, depending on whether we're in degrees or radians, that has the same sine value as the following. So we have part A and B. So let's work with part A first. So we have 80 degrees here. So let's find 80 degrees first of all. So we have this circle, okay? And here's 90 degrees all the way at the top, right? And 80 degrees is only 10 degrees away, so it's up there, okay? So here's 80 degrees, and the sine value is the y value, right? So here's y, which is sine. So what we want to do is find an angle that has that same y value. So what I'm going to do now is just draw a horizontal line, because this is that at that particular y value, okay? So sine of 80, it has a certain value, right? And it's up here, okay? So we want to find another point on our circle, or another angle, which gives us that same y value, right? And that would be kind of like overshooting by 10 degrees past 90, okay? So because 80 degrees is 10 away from 90 on the right side, because our unit circle is symmetric, or any circle is symmetric, then we have that on the left side of 90, if we go 10 degrees that way, we should also get that same sine value, okay? So we're just going to say 90 plus 10 degrees, that gives us 100 degrees, and that's going to be another angle which has the same sine value as 80, okay? Now if we look over at part B, we have 4 pi over 3, so let's find 4 pi over 3 first of all. So here's 1 pi over 3, 2 pi over 3, 3 pi over 3, and here's 4 pi over 3 there. Okay, so 4 pi over 3 is down here, and if we do the same thing, we want to find something with the same y value there. Okay, so the same y value being this part. So if I just draw that horizontal line, we're going to find it also at, and this is actually going to be 5 pi over 3, and I'll explain why. So that's because we are pi over 3, we are pi over 6 away from 3 pi over 2. I know, it's a lot of fractions and things, but basically, if you move this way, you're going to encounter an angle of, let me draw that a little bit better. If we move this way, that bold area there, we are pi over 6 away from 3 pi over 2. And if we move pi over 6 away this way, then we're pi over 6 away from 3 pi over 2, which that means it's symmetric. So again, like on part A, because we move 10 degrees in either direction from 90, here we're moving pi over 6 radians away from that vertical axis. Okay, so we're going to have that same sine value for the angle of 5 pi over 3. Okay, and you can always, for me, I like to think of things in terms of pi over 6. So another way we could say this is that, let's say we have something like that, okay? 4 pi over 3 is the same as saying 8 pi over 6, okay? 3 pi over 2 is the same thing as saying 9 pi over 6. And 5 pi over 3 is the same thing as saying 10 pi over 6. So this might be a little bit easier to see, maybe a lot easier to see, because we're pi over 6 away in this direction, and we're pi over 6 away in that direction. Therefore, the y values were symmetric here. Okay, they're equal. Alrighty, so this final question is just kind of testing whether you can find an xy coordinate given radius and an angle. And the thing is that we can, right? So the first thing we can say is, okay, let's say if we draw a circle, okay, and we have a radius of 15, so that's a pretty big radius, right? And we have an angle of 220. So let's find 220 first of all. So this is going to be 180 degrees. That's halfway around. This is 270. So 220 is somewhere in here. It's 40 degrees past 180. So 220, that's not one of our commonly known angles. It's not like, 225 would be a known one because that's 45 degrees past 180. We don't really know what 220 is, so we're going to have to plug that into a calculator. So the thing is that an xy point is equivalent to saying r times cosine theta, comma, r times sine theta. So if we just plug things in here, we know our radius is 15, so we can plug in 15 for r. And we know our angle in terms of degrees is 220, okay? Again, our radius is 15, and we're going to plug in that same value of 220 in for the angle theta. So if you were to plug these into your calculator in degrees mode, not in radians, but in degrees, because we're using degrees, then we would get an answer of about negative 11.49 for the x value, and negative 9.64 for the y value. Okay? And that's pretty much it. Alrighty, so that wraps up our practice problems video on the section on points on circles using sine and cosine. I hope that helps, and good luck on your homework.